Welcome back students to the chapter Haloalkanes and Haloarenes of class 12. This is part 14 of this chapter, and in this part we are going to see about the preparation of haloalkanes from alkenes. So haloalkanes we have already prepared from alcohol. We have seen preparing it from alcohol, and also we have seen preparing it from hydrocarbons. Alkene is also a hydrocarbon, but an unsaturated hydrocarbon. So far we have seen this from saturated hydrocarbon, and next what we are going to see is from unsaturated hydrocarbons. So generally, if you are preparing it from alkenes, it is an addition reaction. So if you are preparing haloalkanes from alkenes, then such reactions are called addition reaction. We will see that why it is called so. So you can generally classify this type of reactions into two. The first one is alkenes converted to monohaloalkanes, and the next one is alkenes into polyhaloalkanes. So what is the difference between mono and poly? We have already seen. Monohalo means alkanes having only one atom in it, only one halogen atom in it, whereas polyhaloalkenes means having more than one halogen atom in an alkyl chain. So accordingly we have two types of preparation, two types of reagents we will use in this part. Now next is alkenes are of two types, symmetrical alkenes and unsymmetrical alkenes, and it is an addition reaction. Correspondingly you will have two different ways of approach, two different ways of products obtained. When we are using symmetrical alkenes, you will get one type of product, and if you are using unsymmetrical alkenes, you will get multiple products. We will see that in detail. So first what we are going to concentrate is alkenes to monohaloalkanes. So first we will see monohaloalkanes from a symmetrical alkene. So symmetrical alkene means, we will see the definition. What are symmetrical alkenes? Are alkenes with same alkyl groups on both sides of the double bond. So for example, let us see the example here. You have double bond here, and if you are looking onto the left and onto the right, leftilum rightilum, you have the same group. Also in the second example, you can see on the left you have two carbon compound, and on the right also you have a two carbon chain. So which means that this is also an example for a symmetrical alkene. So what are symmetrical alkenes? Symmetrical alkenes are alkenes with same alkyl groups on both sides of the double bond. So we have same alkyl group on the both sides in both these examples. So this is ethene and this is but2ene. So here, so straight away I am using ethene C2H4 for the preparation of monohaloalkanes. So what has happened here? You can see when you go from a reactant to product, what happened? This double bond is broken on here, isn't it? So it has turned into a single bond, and onto each carbon atom new atoms onto each carbon atom new atoms are added, isn't it? So here H is added, and on this carbon atom X is being added. So since it is since it is addition of atoms, you call this reaction as addition reaction. So whenever you have an unsaturated bond, and if you are breaking it and you are adding atoms into it to compensate that bond, then it is called addition reaction. So what are the things that are added here? On the left it is H, on the right it is X. So it is easy to predict what might be the thing that you have added, what might be the reagent that you have added here. It is nothing but HX, that is hydrohalic acid. Clear? So if you have an alkene, in this case it is a symmetrical alkene, you just add hydrohalic acid. Onto one carbon H will be attached. Onto the other carbon X will be attached. So what is X here? X can be chlorine, bromine or iodine. Chlorine, bromine, iodine. So here ethene is now a haloethane. Haloethane. Clear? That's what you will get in mono haloalkane. So haloethane. So if it is chlorine, then it is chloroethane. If it is bromine, then bromoethane. And if it is iodine, then it will be iodoethane. Clear? Now let us look into the next example. Another symmetrical alkene that is given here. So you have here. While we explain this, here I have taken HBr. We will see what is happening actually. When you are adding HBr, what is happening in this molecule? What happens is, in the presence of HBr, one bond, that means the sigma bond, the pi bond will move from here to one of the carbon atom. So pi bond from here will move into one of the carbon atom like this. So it will move either to left or to right. Clear? Since it is a symmetrical alkene, doesn't matter where it is moving. Either it can move on to the left or onto the right. So here I am showing it is moving on to the left. So if this pair of electron is moving on to this carbon, what happens? This carbon will be now negatively charged, which we call it as carboanion. So if this pair of electron, this pi bond here, if it is moving on to this carbon, now this carbon will be negatively charged, or you call it as carboanion. And what happened for this carbon? This will become positively charged. So this will be, so I will write it here. Once after this electron is moving on to this carbon, this will be negatively charged and this will be positively charged. Clear? Now we have HBr. What in the presence of HBr this is happening. Clear? Now we have HBr. Which is positive and which is negative here? We know that Br is electronegative. So this negatively charged Br will prefer which carbon here? He will prefer positive carbon. So Br will come and attach to positive carbon. And what is remaining? We have H plus. H plus will move to negatively charged carbon. So this is what is happening in the reaction. So H will move to the negatively charged carbon and Br will move to the positively charged carbon. And hence we have a mono haloalkene. So we have Br attached to this carbon, and H, which will give CH2, CH, Br, CH3. So this is what is happening in the reaction. A double bond is broken and broken double bond will move completely to one carbon, giving it a negative charge, whereas the other carbon will get a positive charge. Automatically HBr will move, H will move to the negative charge and Br will move to the positive charge. So this is what is happening in the reaction in the addition reaction of alkenes with hydrohalic acid, in this case hydrogen bromide. So let us see the names of these compounds. What is the name? Can you name this compound? Yes, we have already seen here. The name is 2-butene or but-2-ene. Both names you can call. So it is but-2-ene or butene. 2-butene. Clear? And here in this case it is on the second carbon, so 2-bromobutane. So this is about the symmetrical alkene. Now let us assume that this electron is moving on to this carbon. If the electron is moving on to this carbon will be negatively charged and this will be positively charged, isn't it? Then Br will be moving to here. Instead of this one, Br will be here and H will be here. So is it the same compound? If Br is here and H is here, yes. If Br is here, if I number again, it will be the same compound. That's what I said. It doesn't matter where the electron is moving in the case of symmetrical alkenes. In the case of symmetrical alkenes, doesn't matter either of the carbon atom can move because it's the same compound you are going to get if it is moving to this carbon or even if it is moving to this carbon. അപ്പം ഏത് കാർബണിലേക്ക് നീങ്ങിയാലും എനിക്ക് കിട്ടാൻ പോകുന്നത് എന്താണ്? സെയിം പ്രൊഡക്റ്റ് ആണ്. അതുകൊണ്ട് സിമെട്രിക്കൽ ആൽക്കീൻസ്, ഇൻ ദ കേസ് ഓഫ് സിമെട്രിക്കൽ ആൽക്കീൻസ്, it doesn't matter to which carbon it is moving. Clear? അപ്പം ഈ രണ്ട് കാർബണിലെ ഏതെങ്കിലും ഒരു കാർബൺ നമുക്ക് എന്ത് ചെയ്യാം? ചൂസ് ചെയ്യാൻ പറ്റും. Clear ആയി? So that's about the symmetrical alkanes. Now let us consider preparation of monohaloalkanes from unsymmetrical alkenes. Unsymmetrical alkenes. So what are unsymmetrical alkenes? They are the alkenes with different alkyl groups on both sides of the double bond. So if we have alkenes with different alkyl groups on both sides of double bond, then they are called unsymmetrical alkenes. Clear? So for example, propene. So propene is the example. You can see on the either side of the double bond, on the right hand side we have only one carbon, on the left hand side we have two carbon. So such an alkene is called unsymmetrical alkene. Clear? And propene is the first example of that type. The very first member of the unsymmetrical alkene is propene, which has one carbon on the right and two carbon on the left. So it is an unsymmetrical alkene. So like what we saw in the previous slide, let us see how what happens if the electron is transferring in this case. So we have propene, and in the propene I have added HBr. So to propene I have added HBr. So now this pair of electron here, that is the pi bond, can shift either onto this carbon or it can shift onto this carbon. So I am assuming shifting of the pi bond onto the second carbon as the first case. Clear? So if it is like that, what happens? This carbon will get the electron and it will have negative charge, isn't it? Like this. So this carbon will be, so the second carbon will be having negative charge and the first carbon will be the cation, or primary carbon is the cation. Clear? Now what happens if the electron is moving on to the other carbon atom? Then this will be the anion and this will be the cation. That is the second case. So we have secondary cation here. Here it is primary carbocation. So in this case it is primary carbocation and in this case it is secondary carbocation. And we have studied this in the previous part. Which carbocation is more stable? It is the secondary carbocation. Secondary carbocation is more stable compared to primary carbocation. Clear? So primary carbocation and secondary carbocation, and both carbocation intermediates are formed. Both in the reaction, during the reaction, both will be formed. But secondary carbocation being more stable than primary, major intermediate formed will be secondary. Clear? So both will be formed, but this is comparatively more stable. Comparatively more stable than the primary. So what happens? There will be both intermediates. Among them, secondary will be the major intermediate formed. Clear? Now, if HBr is moving, since both are present in the solution, both will be present, both intermediate will be present in the solution. Now HBr, if it is moving, in this case, in the second case, H will move towards CH3 and Br will be binding on the secondary carbon. Br will be binding onto the secondary carbon. Whereas if it is moving on to the first case, Br will be attached on the primary carbon and H will be attached here. So both product will be formed, but which will be the primary or which will be the major product? Major product will be Br attached to the central carbon or the secondary carbon atom. Is it clear? So if it was a tertiary carbon atom, then Br will go to there. So here it is, in this case it is secondary more stable than primary. So Br will get attached to the secondary and it is the major product. This product also will be there, but it will be only less than 20%. almost 80% of the product will be with this carbon, with this Br attached to this carbon, secondary carbocation. So let us see that. So as I said in the previous slide, we have primary carbocation and secondary carbocation, in which both will be formed in the solution. In the solution, if you look into the solution, both will be there. But the secondary carbocation, being more stable, will be the major product. So what happens then? So if I am adding HBr into propene, as I said, I will have both product, Br on the secondary carbon atom and Br on the primary carbon atom. As I said, which will be the major product? The Br on the secondary carbon atom, because carbocation, secondary carbocation is more stable. So major product will be this one and minor product will be this one. Clear? And a scientist known as Marconicos has made it into a rule to easily identify the major product. So that's called Marconicos rule. In alkene addition, H of HX means in this is HX, in this H will prefer carbon of alkene. Which carbon will it prefer? It will prefer, the H will prefer carbon with more hydrogen. So he will look into both the hydrogen, and if he sees one hydrogen is having more number of hydrogen atoms, he will go there. Clear? So C of alkene with more H atom will be preferred. So H will prefer this carbon, that you can see this is the major product. If H is going here, it is the major product. So this is called Marconicos rule, or Marconicos has given a set of rule where you can easily identify the major product. So major product is that hydrogen will be added to carbon which has more number of hydrogen atom. Hydrogen of this HX will be added onto a carbon that has more number of hydrogen. So this is the carbon that is having more number of hydrogen. So H will be added here. So it will be like this, CH3. Then Br will be added onto this carbon. So this is called Marconicos rule. In alkene addition, H of HX prefer carbon of alkene with more hydrogen atom. I guess it is clear. Now, what if I want to make this as the major product? I want to get primary substituted, or in the addition process, if I want to have Br on the primary carbon atom, and I want that as the major product. And there is another rule called as anti-Marconicos rule. For that, I have to, along with HBr, I have to add an organic peroxide. Organic peroxide. Organic peroxide means a compound that contains OOH. So let us see an example for organic peroxide. This will be an example, will be a good example for that. So I have benzene ring. Okay, then on the benzene ring I have OOH. So this bond is called peroxide, and if it is attached or if it is with an organic compound, so it is called, or it has the ability to reverse the reaction, reverse this Marconicos reaction. What happens due to, there is a special mechanism for that, since it is not it is beyond the scope of our syllabus, we will not discuss that. So if there is organic peroxide, what happens? Minor will become major and major will become minor. So that's called anti-Marconicos rule. H of HX prefer C of alkene with less H atoms, provided there should be an organic peroxide in this reaction. Clear? So for propene, from propene, if you want to get the primary carbocation as major product, this, if it has to be major, then you have to add an organic peroxide. So let us look into an example here for Marconicos and anti-Marconicos based on propene itself in the next slide. So we have Marconicos addition. In the Marconicos addition, we are just adding HBr, and you will get the product like we mentioned in the previous slide. Major product will be 2-bromopropane and the minor will be 1-bromopropane. Whereas in the case of anti-Marconicos addition, so here the minor and major has interchanged. Minor is now 2-bromopropane and 1-bromopropane has changed into a major product. Clear? So this is all about the addition reaction of unsymmetrical alkene for monohaloalkanes. Thing is, in the case of symmetrical alkanes, you will have only one product, whereas in the case of unsymmetrical alkenes, you will have two products. One will be major and the other one will be minor. Major will be where we have this carbon or this secondary carbon where it is more stable, and it is called Marconicos addition. If you want to reverse the minor and major products, then you have to add an organic peroxide. If you are adding organic peroxide, it will be reversed. Clear? So that's all about the addition reaction of unsymmetrical alkenes for obtaining monohaloalkane. So we have completed with these three topics, that is monohaloalkanes. In that we saw symmetrical alkenes, and secondly we saw unsymmetrical alkenes. To recollect it, what was symmetrical alkenes? I was just adding HBr and HX, and you are getting only one type of product. Whereas in the case of unsymmetrical alkene, you are adding hydrohalic acid HX, but what you are getting is major and minor. And you have seen Marconicos and anti-Marconicos rule. Next, what we are going to see is alkenes to polyhaloalkanes. Clear? Alkenes into polyhaloalkanes. So next is polyhaloalkanes addition reaction of alkenes. So let us start. We have propene here, and we have into that propene I am going to add bromine that is dissolved in CCl4, carbon tetrachloride. So I am adding bromine dissolved in CCl4 into propene. So it doesn't matter in this reaction whether it is symmetrical or unsymmetrical. We will see why. If you are adding bromine in CCl4 that into a compound that contains unsaturated bond, for example that has a pi bond, what happens is bromine will break this bond, and one bromine will get attached to this carbon and the other bromine will get attached to this carbon. Clear? So it will be like this. So this bond is broken, and one bromine atom of this molecule is attached to this carbon and the other atom is attached to this carbon. Now the compound has turned colorless, or the color of reddish brown has gone because it is the color of bromine element. Now it is part of the molecule. Clear? So the name of this, or we have studied this type of compound, that is vicinal bromoalkanes. Vicinal means if two neighboring carbon atoms are having bromine, then it is called vicinal halides, isn't it? Vicinal dihalides. So in this case you have bromine on the neighboring carbon atoms, so it is called vicinal dihalides. Clear? Now reddish brown bromine gets decolorized if the compound has an unsaturated double bond or triple bond. Even if there is triple bond also, this reddish brown is gone because it will break that bond and bromine will be added into it. So in the lab you use this combination bromine in CCl4 to see whether the compound is saturated or unsaturated. Clear? So if I am adding bromine into it and if the color is gone, which means that the given compound is unsaturated. അപ്പോൾ നമുക്ക് ലാബിൽ ഒരു കോമ്പൗണ്ട് തന്നു, അതിലേക്ക് ബ്രോമിൻ that is dissolved in CCl4 is added. If the color is gone, that means the compound contains a double bond or a triple bond. That is, compound is unsaturated. If it was saturated, bromine cannot be added into the compound. So that means if there is no decolorization, color മാറുന്നില്ല solution എങ്കിൽ, then the given compound is a saturated compound. So that's the reason why bromine in CCl4 is used as a reagent to test the unsaturation. So let us see what happens if it is a triple bond. So if it is a triple bond, what happens? Bromine will cleave both pi bonds. So one sigma bond and two pi bonds. Both these pi bonds will be cleaved, and what happens? You will get on each carbon atom there will be two. So it is vicinal as well as geminal. Geminal means if one carbon has two halo groups, then it is called geminal. So at the same time it is geminal because this carbon is having two halo groups. And at the same time it is vicinal. That means each neighboring carbon has halo groups. So it's geminal as well as vicinal. So which means that bromine in CCl4 can be used to test the unsaturation, whether the compound is saturated or unsaturated. Clear? So let us summarize the reactions that we saw in this part. We have seen alkenes to monohaloalkanes, which involved symmetrical alkenes and unsymmetrical alkenes. For symmetrical alkenes, you will get just one product. So if you are considering the reagent, it is HX that is adding here. X can be chlorine, bromine or iodine. For symmetrical alkene, you will get only one type of product. For unsymmetrical alkene, you will have one major and one minor according to Marconicos and anti-Marconicos rule. Now, from alkenes to polyhaloalkanes. What are the reagents that we used? If you recollect it, it is Br2. So not X2. So Br2 is the general thing that you use. Br2, reddish brown Br2, that is dissolved in CCl4. Clear? You can also use chlorine, but generally we use Br2 in CCl4 to test the unsaturation. So what happens? If it is a double bond, you will get vicinal dihalide. If it is a triple bond, you will get geminal and vicinal dihalides. Geminal means two halo on the same carbon atom. Vicinal means a halo group or a halogen atom on adjacent carbon atoms. Clear? So this is what we have learned in this part. Okay, thank you.